Hello everyone, welcome to Module 5. Here we discuss robotics and automation in the context of Industry 4. So in Industry 4.0, robotics has evolved from performing simple repetitive tasks to executing highly complex and adaptive operations. So advanced robots are now equipped with the cutting edge technologies like AI, ML, and IoT. So these innovations allow robots to not only follow pre-programmed instructions, but also learn, adapt, and optimize their performance over time. So for example, AI enables robots to analyze large volumes of data and recognize patterns and predict outcomes, which is invaluable for quality control and predictive maintenance. Likewise, IoT allows robots to interact seamlessly with other devices in a smart factory, ensuring smooth workflows and real-time communication. So, robotics is a crucial enabler of automation in modern manufacturing. So, since it lies at the heart of automation in Industry 4 and it also addresses key manufacturing goals. So, robots work tirelessly and consistently, drastically reducing cycle times and production costs, enabling efficiency. At the same time, advanced robotics ensure a high degree of accuracy, crucial in industries like semiconductor manufacturing or medical devices, ensuring high precision. Finally, robots can easily scale operations to meet varying production demands without significant delays or errors, enabling scalability. Then, they've got the ability to integrate with other advanced technologies. So, to meet the demands of modern manufacturing, robots can are being enhanced with enhanced vision systems. So cameras and sensors provide robots with the ability to see their environment, enabling them to identify objects and carry out tasks with greater accuracy. Also, traditional robots were designed for single tasks. Now, modern robots use AI to adapt to new tasks without extensive programming, thereby providing high degree of flexibility. Finally, when it comes to adaptability, collaborative robots or cobots are designed to work safely alongside humans, making them ideal for environments requiring a mix of human ingenuity and robotic efficiency. Finally, the real-time data feedback for autonomous decision making, they provide that. So for example, in a smart factory, robots are not just executors, they are thinkers as well. So here's how real-time data feedbacks come into play. So with the start of sensors and IoT devices, robots collect data about their environment and processes, be it about vibrations or parts alignments or temperature, etc. Then with this data, robots can adjust their actions autonomously. For example, if a robotic arm detects an anomaly in a component's position, it can realign it without human intervention. Then these ensure continuous learning and improvement. So a robot might refine its grip length or adjust its speed based on historical data trends. So all in all, advanced robotic systems are a cornerstone of Industry 4, driving automation and transforming manufacturing processes. By integrating AI, IoT, and real-time feedback, these systems not only enhance productivity but also make manufacturing smarter, more efficient, and adaptable to future challenges. So, if we explore human robot collaboration, so this is all about blending the strengths of humans and robots in a shared workspace. So while robots bring precision, consistency, and speed, humans contribute creativity, decision making, and adaptability. So designing the workspace to facilitate this synergy is key to maximizing efficiency and safety. So if you understand about the importance of proper layout and safety measures, so the workspace layout is critical to ensuring a harmonious collaboration between humans and robots. How it is defining zones for robot only and human only and shared tasks minimizes confusion and enhances safety. So this is all about providing clear zones. Then collaborative robots are equipped with sensors, vision system, and force feedback to detect human presence and avoid accidents. However, proper physical barriers or light curtains can further enhance safety where needed. So this is all about the safety systems. Finally, If you talk about the ease of access, so tools, materials, and cobots should be positioned for ergonomic use, minimizing unnecessary movements for both humans and robots. So, for instance, in an automotive factory, a cobot may handle heavy lifting in one zone while workers focus on detailed assembly tasks nearby, with clear pathways to prevent interference. Then, we talk about designing workspaces for smooth interaction. A well-designed workspace is key to fostering smooth interactions between humans and robots. So, for example, consider the ergonomic design, where workspaces should minimize strain on human workers. Adjustable tables, proper lighting, and easily accessible tools reduce fatigue and enhance productivity. Then, if we have the intuitive interfaces, so robots equipped with user-friendly interfaces like touch screens or gesture controls or voice commands make collaboration seamless even for non-technical workers. Then, if we talk about proximity and positioning, so robots should be placed within optimal reach for humans to facilitate quick handovers, reducing downtime during collaborative tasks. Then, if we talk about the task allocation, we need to leverage strengths. So, to maximize productivity, tasks should be allocated based on unique strengths of humans and robots. So, for example, robots excel at repetitive tasks like assembly or welding, and high precision operations like electronics soldering, or handling hazardous or physically demanding tasks like chemicals mixing. Then we have humans where they excel at decision making and problem solving. Then creative and nuanced tasks, something like product customization, or tasks requiring emotional intelligence like customer interactions. Finally, we need to have a look and ensure about design considerations. So while when designing human robot collaborative workspaces, several factors come into play, starting with the ergonomics. So we need to reduce repetitive strain injuries by ensuring tools and robots are positioned at ergonomic heights. Then we need to allow for natural human movements without obstruction. Then, to ensure flexibility, workspaces should adapt to changing production needs. Modular layouts and movable robots can accommodate different tasks or products. Finally, to ensure task complexity, so simple repetitive tasks can be fully automated, while more complex tasks might require a mix of robotic precision and human oversight. So in order to wrap up, designing effective human robot workspaces is a strategic effort that enhances productivity, safety, and collaboration. By considering ergonomics, task allocation, safety, companies can unlock the full potential of human robot teams. So let's delve into ISO TS 15066, which is the international safety standard designed to ensure safe and effective human robot collaboration in Industry 4 environments. So, what exactly is ISO TS 15066? So, it is a technical specification specifically created for collaborative robots or cobots. So, it is an extension of the General Robot Safety Standard, which is ISO 10218, focusing on the unique challenges of human robot collaboration. So, the key goal of the specification is to provide a framework that ensures cobots can safely share workspaces with humans without causing harm. If we understand few of the key aspects of the specification, it starts with a safety requirement for cobots. So these cobots must be designed to minimize risks, especially when operating in close proximity to humans. So the standard emphasizes inherent safety features such as rounded edges, smooth surfaces, and limited force capabilities to reduce the chance of an injury. Then cobots must include built-in mechanisms to detect human presence, such as sensors or cameras, ensuring they can stop or adjust their actions if necessary. Then they have the guidelines for safe human robot interaction. So ISO TS 15066 provides detailed guidelines for the design and deployment of collaborative workspaces, including separation distances, which is maintaining a safe distance between humans and robots when necessary. Then force and pressure limits. So setting thresholds for the amount of force and pressure a robot can exert to avoid an injury, These limits are based on human tolerance data for various body regions. It also recommends using risk reducing measures like a safety rated monitored stop functions or reduced speed modes during collaboration. Then it has a risk assessment framework. So the standard emphasizes the need for a comprehensive risk assessment before deploying cobots in the workspace. So for example, identifying hazards. So assess all the tasks, movements, and potential failure modes of the cobot, then analyzing risks. Consider the likelihood and severity of potential injuries, then mitigating risks. So implementing safeguards such as protective stops, reduced force settings, or operational barriers. So regular monitoring and updates to the risk assessment are crucial as processes or tasks evolves. So physical safety is at the core of this specification. So for example, if a cobot accidentally comes into contact with a human, it must stop immediately and exert only a force within predefined safe limits. Then, cobots often use sensors to detect when humans enter their work zones, enabling dynamic adjustments like slowing down or halting operations. So, all in all, ISO TS 15066 specification is a vital guideline for ensuring the safety of collaborative robots in Industry 4 environments. It bridges the gap between the technological innovation and workplace safety by defining how humans and robots can safely interact.